Hey everyone, welcome back. This is lesson 10.5, Parabolas. By the end of this lesson, you're going to be able to write the standard equation of a parabola and its axis of symmetry. You're also going to be able to graph a parabola and identify its focus, directrix, and axis of symmetry. Your vocabulary for today is focus of a parabola and directrix. In Chapter 5, you learned that a graph of a quadratic function is a parabola. Because a parabola is a conic section, it can also be defined in terms of distance. All right, for the definition of a parabola, we're going to use this term again that we've talked about before, the set of all points, all right, in a plane that are equal distance from both a fixed point, here we go, a fixed point, and the focus, and a fixed line. This is kind of an imaginary line, like our axis of symmetry. This fixed line is called the directrix. All right, so we're going to have all the points that are equal distance. So they're the same distance from here to here. So in other words, the distance from PD to PF is the exact same. And anywhere, any point you choose is going to be the same. The distance, let's say I chose this point. Everything from here to here is the exact distance. All right, so this line is called the directrix, and this point up here is called the focus. The vertex of a parabola is the midpoint of the perpendicular segment. So this vertex right here is the midpoint of the perpendicular segment connecting the focus and the directrix. So it's right in between this focus and the directrix. That's where our vertex is. Remember, the distance from a point to a line, so let's say if I have a point here and I have a line, the distance from a point to a line is defined as the length of the line segment from the point perpendicular to the line. So it's going to be perpendicular right here. That's the distance from a point to a line. A point to a line could be over here, could be over here. We could do any of those, but what we're going to be measuring is the point to a line where it's perpendicular. Example 1 tells us to use the distance formula to find the equation of a parabola with a focus at 2, 4 and a directrix at y equals -4. Now let me just review what we've kind of talked about already. Because my focus is up here, my directrix is down here, halfway between the point, the focus, and the directrix is my vertex. Now the focus is always inside the parabola and the directrix is always outside the parabola. So I'm going to draw my parabola like this. Okay, next thing I need to do is let's think about what the definition of the parabola is. The definition of the parabola says that from the focus to some point this distance here is going to be the exact same from that point to the directrix. All right, that's going to be the same. So they're going to be equal to each other. So let's write the distance formula out. And here it is. And let's talk about what we have here. We know our focus is 2, 4. And my point out here, I don't know what that point is. So I'm just going to call that point X and Y. All right. So I have X, Y, but I don't know what they are. And I do know that I have a point at 2, 4. Now let's talk about this other point for my D down here. I don't know what the X is, so I'm just going to call that X, but I do know my Y is -4. So I'm going to, again, use P as X and Y, and I'm going to use for my D the X and -4. All right, so now I'm going to go ahead and substitute those all into my equation. Notice my X, this is from my P, and my Y, that's from my P. And then the -2 and -4, that comes from my focus. Over here on the other side, again, I have my P and my P, my X and Y and my P. And then the X is for the point that I don't know. And then the 4 is my -4 here. But remember, our distance formula says to subtract, so that's why there's a plus there now, because a minus and a negative make a positive. All right, so once we have substituted everything in, we can start solving and simplifying. All right, so here's our problem simplified, but we need to keep going more because this in the square root is not very helpful to us. So let's go ahead and square both sides. So when we square both sides, we're getting close to a good equation, but we need to go ahead, first of all, and expand. And so what I want to do first is I'm going to expand this y plus 4 squared and the 4 minus y squared. And I want you to be careful to remember that's not going to equal y squared plus 16. That is wrong. You have to actually work it out. Y plus 4 times y plus 4. And when we do that, we get y squared plus 4y plus 4y plus 16. All right. Now, when you do, this next part is not quite as easy for you to look at, but if we just expand these two, and you may end up expanding all of them and having to go back at first before you start understanding how this is kind of working. I can see that if I subtract y squared from both sides, all my y squareds go away. And also if I subtract 16 from both sides, my 16s go away. So now if I go ahead, because remember I'm trying to solve for y, so let's go ahead and subtract y squared and 16 from both sides. And we end up with x minus 2 squared minus 8y equals 8y. Well, the next thing what we want to do is go ahead and add both 8y to both sides. And that gets our 8y or our 8y onto one side and our x is on the other. So we have 6x minus 2 squared equals 16y. Next, we want to go ahead and solve for y. And so we see that y equals 1 over 16 times x minus 2 squared. And there's your equation for your parabola. All right, try this one on your own. Turn off your video and give it a try. Okay, let's do this one together. It says use the distance formula to find the equation of the parabola. It tells us that our focus is at 0, 4. So over 0, up 4. So here's my focus. And my directrix again is at y equals negative 4. So I have here. All right, and once again, that tells me the distance between 4 and negative 4 is 0, halfway. So, and my parabola always opens up with the focus inside. All right, and once again, let's remember our definition of a parabola. From the focus to any point is going to be, this distance is going to be the exact same as this distance. All right, so this is my F, which is 0, 4. My P, I know nothing about. That's going to be my X and Y. And my D is going to be X and negative 4. All right, so I have all of my points that I need. So now I'm going to use my distance formula. Here it is written out. So again, I'm going to be substituting in. Remember, these are my points for my P. All right, the points from F were 0, 4, but remember my distance formula says minus, so that's why there's a minus there. And then for my P to D, the distance from P to D is X and Y, so there's that. And then my D is going to be X negative 4. So there's my X and negative 4, which would be added together there. All right, so let's keep on simplifying next. So when we simplify it all out, we can again need to square both sides. And now, once again, we need to expand it by multiplying it out. Again, we can subtract our y squared and 16 from both sides, and we end up with x squared equals 16y. So we want to solve for y. So y equals 1 over 16 times x squared. And this is your final answer right here. All right, previously you have graphed parabolas with vertical axis of symmetry that open upward or downward. Parabolas may also have horizontal axis of symmetry and may open to the left or right. The equations of parabolas use the parameter p. The absolute value of p gives the distance from the vertex to both the focus and the directrix. Let's see what that means. Take a look at this chart. Let's look at the vertical first because that's what we're most used to seeing. Y equals 1 over 4 little p x squared. Remember, this little p represents this distance from our point to the vertex and also from our vertex to the directrix. It opens upward if p is greater than 0, and if p is less than 0, it's going to open downwards. All right, so our focus is for the parent function is going to be at 0p, and the directrix is going to be at the opposite of p, just like what we were doing just a minute ago on our other problems. Again, for the horizontal parabola, notice that this time it's x and the y is squared. All right, over with the vertical, we always had y equals and our x was squared, but now it's going to be x equals with our y squared. Again, this little p tells us that if the p is larger than 0, it's going to open to the right, positive, and if it were negative, it would open to the left in the negative. All right, again, our focus is at P0, and the directrix is going to be exactly opposite that for our parent function. Example 2 tells us to write the equation in standard form for the parabola. This time again, notice that we've got our focus at 0, -5. And since our focus is down here, we know our parabola is facing downward. That P is negative. All right, and our directrix is positive, y equals 5. So, because the axis of symmetry is vertical and the parabola opens downward, the equation is going to be in this form. Y equals 1 over 4p times x squared. And p in this case is less than 0. All right, step 2. We're going to take the distance from the focus, which we said was at 0, -5, to the vertex. I see that this distance is 5. All right, so P is going to equal -5. All right, and so 4P is -20. So now all we need to do is the equation of the parabola is going to equal y equals -1 over 20 x squared. Because remember, our formula was going to be y equals 1 over 4p times x squared. So we found our p to be -5, and then when we multiply 4 times -5, we get 20, -20. So that's where our negative comes in. And you can always put this in your calculator and check it. Use your graphing calculator, and it does appear to be what we hoped it would look like. All right, let's try another one. This time we're going to write the equation in standard form with a vertex at 0, 0 and a directrix at x equals -6. So we're just going to have to use a little bit of reason on this. Let's see the things that we have. All right, we know that our vertex is 0, 0, and our directrix is at x equals -6. So we have to think about what that looks like. 1, 2, 3, 4, 5, 6. All right, my directrix is right here. Okay, so that is this line right here. Now it said my vertex is here, so my focus must be 6, because this distance is 1, 2, 3, 4, 5, 6. So I have to go the same distance to get to my focus. 1, 2, 3, 4, 5, 6. So there's where my focus is. And so now, if my focus is here, my parabola focus has to be inside the parabola. Directrix is outside of my parabola. Okay, so now I know that my P is actually going to be 6 because I'm 6 away. So let's go ahead and get all this information in. Here's the formula that we're going to use because the directrix is a vertical line. The equation is going to be in the form x equals 1 over 4p y squared. The vertex is to the right of the directrix, so the graph will open to the right, just what I said. So let's keep on moving. So we know what our p is, and we know what our everything's supposed to look like. Because the directrix is x equals -6, p equals 6, and 4p equals 24. Now remember what our equation was going to be. X equals 1 over 4p y squared. So we know what our p, 4p is 24. So now all we have to do is just put our equation out, and we see that x equals 1 over 24 times y squared. Again, we can use the calculator to graph it, and that's what it looks like, kind of the same way we sketched it out. All right, turn your video off and try this one on your own. All right, so let's talk about the information that we are given and what we know about our parabola so far. So the first thing we know is that the directrix is a vertical line. And how do I know that? Well, let's just draw it in and we'll see. It says that my vertex is at 0, 0, and my directrix is at x equals 1.25. So let's just say this is 1.25 here. All right, that tells me that my focus is going to be at negative 1.25, comma 0. So there's my focus point, and my focus has to be inside the parabola. So we're going to draw it like that is what it's going to look like. Now, what I need to know, I can go ahead and set up my equation. X equals, because it's horizontal now, x equals 1 over 4p times y squared. So what is the p? Well, p is going to be this distance here, and we know this distance is 1.25, okay? But my parabola is facing to the left, so we're going to use negative 1.25. All right, so because x is 1.25, the p is negative 1.25, so 4p is negative 5. So now we could just write our equation. X equals negative 1 over 5 times y squared. And again, putting it in the calculator, it does indeed look like something what we sketched out ahead of time. Try this one on your own. Turn the video off and give it a try. Okay, again, you have to use the information that you're given and think about what you're given. So what we know is we know our vertex is at 0, 0. All right, and we know there's a focus at 0, negative 7. So 1, 2, 3, 4, 5, 6, 7. We have a focus here. That means our directrix has to be 7 up. All right, so here's my directrix way up here. All right, so my parabola has to open with the focus inside. All right, and so I know that my distance here is 7. All right, so my p is going to equal 7, but it's actually going to be negative 7 because notice my parabola is going down. So my p is going to be negative 7. Now, it's a vertical parabola, so we're going to do our normal y equals 1 over 4p. Well, 4 times negative 7 is negative 28, and so you can guess what the new equation is going to be. Y equals negative 1 over 28 times x squared. And again, putting it in your calculator, we can graph it and see, yes, it does indeed look like what we kind of sketched out a little bit. All right, the vertex of a parabola may not always be the origin. Adding or subtracting a value from x or y translates the graph of a parabola. Also notice that the values of p stretch or compress the graph. Here's a chart for that. Again, just like we've been doing before, we've got our equation x minus h, y minus k. So that's going to tell you where your center is. All right, again, if p is greater than 0, it opens to the right on the horizontal. If it's greater than 0, it opens upward on the vertical. And of course, the negative will open to the left and downward. All right, our focus now is going to be at h plus p for our x component and k for our y component. And for the vertical, it's going to be h and then k plus p. It seems kind of complicated, but once we get started looking at it, you'll see that it's not that hard at all. All right, so number 3 has a lot of parts that we had to do. So let's go piece by piece. So the first thing says to find the vertex. So to find the vertex, we're going to say, what should y be to make that 0? And that would be -3, and this would be +2. Be careful not to go ahead and just say, oh, the vertex is at -3, 2, because remember, this y is associated with our -3. So it's actually going to be 2, -3, like that. Okay, that's where our vertex is. So we've got our vertex now. And now that we have our vertex, we can think a little bit more about our equation. Notice that this is written in the y equals 1 over 4p x squared format. Because see, our x is the 1 squared. So when y has an exponent of 1 and the x has a square, we know that our parabola is going to be facing upward or downward vertically. All right, so the next thing we need to do, we're asked to do, is find the value of p. All right, so in this format, we can see 4p is equal to 8. All right, so we could just set up a really easy equation. 4p equals 8. Divide both sides by 4, and we see that p equals 2. All right, so there it is. So let's not forget what that means. That tells us so. All right, so we have our point at 2, -3, and it says that my p is 2. So that tells me 2 up and 2 down, since I'm going like this, is going to be, I'm going to have my directrix down here. Why did I know that? Well, p is +2. That means my parabola is going to open up. All right, since p is +2. So the focus has to be inside. My directrix is outside. So that tells me a lot right there. Now, I also need to find my axis of symmetry. Well, that's going to be right along the line of my vertex. So my axis of symmetry, and we can abbreviate that AOS, is equal to x equals 2. All right, my focus is at 2, -1. 2, -1. All right, my directrix is at, I'm just going to abbreviate, is at y equals -5. All right, and then we have graphed it already, so now that's all you have to do to finish it. All right, good job. Okay, your turn to try one on your own. Turn your video off and give it a shot. Okay, so this one, the first thing we're supposed to do is find the vertex. So our vertex is going to be, what is x going to be to make this term 0? It would be +1, and y would be +3. So my vertex is going to be at 1, 3. All right, so I think that's pretty easy. Go ahead and let's plot that, 1, 3. All right, the next thing it tells me to do is find the value of p. So let's look at how my equation's written out. I have x equals 1 over 4p times y squared. All right, so that tells me the y squared is what's squared, so my parabola is going to be opening horizontally, either left or right. So let's figure out which way it's going to be. Well, I know my 4p is equal to 12. So let's just solve. 4p equals 12. As you can see that, p equals 3. So I know that my p is equal to 3 and p is positive. So my parabola is going to be opening to the right. All right, so now that I know that, I can go ahead and find my focus and my directrix, because that means I'm going to go 3 to the right, 1, 2, 3 to find my focus. So I'll go 1, 2, 3. There's my focus. And my directrix is going to be 1, 2, 3 this way. So my directrix is a line. All right, and now my focus I can see is at 4, 3. All right, my directrix is at x equals -2. All right, now I can go ahead and draw my parabola in, because I know where my focus and my directrix are. Okay, it asks for this axis of symmetry. Well, that's going to be along this line with my vertex, and so my axis of symmetry is at y equals 3. All right, and just to highlight that a little more, this is where my axis of symmetry is right there, y equals 3. And let's see, I found my directrix, I found my parabola, the focus, axis of symmetry, so we've done it all. That's all we need to do. Try this last one on your own, turn the video off and give it a try. All right, so the first thing I hope you were able to figure out, to find the vertex, we need to look at our x and y's here. So my y is going to be 4, my x is going to be 8. So I know that my vertex is going to be at 4, 8. So I'm going to go ahead and plot that in right now. All right, the next thing I want to do is find the value of p. Well, let's take a look at what my equation, how it's written. And I can see my equation is written in the y equals 1 over 4p x squared. All right, so that means my parabola is going to look like this or like this. So I'm going to need to figure out which way, whether it's up or down. So let's take a look. I have 1 over negative 2. So I can see that 4p is going to equal negative 2. All right, so now divide both sides by 4. We see that p equals negative 2 over 4, which can be reduced to negative 1/2. So my p is going to equal negative 1/2. Since that is less than 0, then we're going to use the parabola facing downward, opening downward. So next, I need to go ahead and put my points in. I got a point at 1/2 up, and I have a point at 1/2 below. So one of each of those places. Now, since I know it's going down, I know my parabola is going to go this way. I know my directrix is going to be right above. And I know that my axis of symmetry is going to be right here. So now that I have everything there, I could just go ahead and find all my points and put them in. I know that my vertex is at 8, 4. My value of p equals negative 1/2. My axis of symmetry, AOS, is equal to x equals 8. All right, so there's my axis of symmetry. My focus is at 8. Let's write that down correctly. My focus is going to be at 8, and it's at 3.5, 3.5. All right, and then finally my directrix is going to be y equals 4.5. And that is your final answer to all of the questions. And that is the end of our lesson 10.5 on parabolas. I hope you understood that okay, and I will see you in class soon.